Good morning, everyone. Thank you for being here. So my presentation will be introducing some terms and definitions we describe mainly into deliverable 4.3 in order for you to understand the concepts we use there in this deliverable. I will present two parts. The presentation is split in two parts. The first one in exactly what I described to you, understand how what is a user story, what is a UML sequence diagram, but also the second part of the presentation will focus on the interoperability challenges, because the main goal is to achieve efficient and reliable communication between systems in order to have a faster and more accurate and more efficient data exchange between systems, but also between organizations. The methodology we use overall in deliverable 4.3 is the scenario-based software engineering methodology. The background behind it is a bit technical because it comes from software developing. But we will use terms that are easy to follow, and there will be so for everyone to understand this. So we focus on this deliverable a lot to the sections of the CSP design phase and CSP monitoring phase. For example, by using tools that can provide data and methodologies to efficiently monitor variables, and also to get those data and establish some baselines for target settings. Also, it's relevant to CSP monitoring and performance review. Now, the reasoning behind why we do this is, of course, to support personnel and technical stakeholders in order they have some guidelines for collaborating and communicating between within their organization, but also within other organizations that their needs must facilitate this communication. And this means by communication we mean to know what are the needs during the early stages of a software solution design. So overall, we try to enhance the CAP governance with a data-driven methodology. So some focus areas are on combining farm level and landscape level data, also to employ methodologies and technologies for real-time data collection and analysis. This includes, of course, systems such as Ajax or LPIS that can act as databases providing information. All this in order to support mainly sustainability goals. Some terms we will see in the next slides revolve around the user story development, which is essentially a structured way to describe a policy question. So the user story is a policy question, is a kind of an expression of the problem. And the unified modeling language diagrams are the way to represent them and visualize them with a clarity, and those can be interpreted by technical and non-technical audience. We also focus on the integration of multi-scale data, as I told you earlier, and interoperability and data governance, since this is the way to ensure the effective data exchange. The reasoning behind selecting the specific domains or thematics of the user stories is that the new FSDN legislation focuses on those, and since they have to do with environmental and sustainability goals, we are ensuring that the deliverable will stay relevant in the future also. So to get more in detail, the core methodology is the scenario-based software engineering. But what I want you to think about this diagram is that the UML diagrams is something more complex than just expressing requirements, but also something less complex than generating code. Nevertheless, the behavior and the relationships between the components are also expressed on the diagram. So if we can see this example, how to read a UML sequence diagram, we have some actors and components. There might be multiple actors or multiple components, and we can read it from top to bottom as time flows from top to bottom and following the arrows. So every row, every arrow is a message sent by a system. So it's a request and a response. This message, of course, is a structured message in order the machine to understand the data that and the metadata it transfers. So you can see that it helps this helps stakeholders, more technical, also more technical audience, to communicate with clarity what is the expected behavior of each component. Or, for example, a component could be a database, could be a system, an Ajax system, could be an FMIS provider. So this is visualized with in a very specific way. This is an example we will explain in detail later. And you can see the actors and the actions and the messages transferred. And also what is, we will explain a bit later, is a visual, let's say, a visualization that is even more simplified for everyone to understand. We will see this soon. We will see those three user stories soon regarding soil health, pesticides, and irrigation practices, along with other information, of course. So the first part of the presentation was this, setting the definitions, but now we have also to mention about the interoperability challenges. As you know, the PMEF shifted the policy focus from compliance to performance. This means increased needs to data digitalization and also data transfer, efficient data transfer between systems. Furthermore, the new CAP regulations updates or gives increased role to member states in order they ensure interoperability and data governance by designating a responsible authority for interoperability and data governance. Exactly, this is how this is done in even more increased importance. In the past, we can say that data are being collected or inefficiently, of course, depending on the member state and depending on the capacity of the respective organizations, which could be statistical authorities, could be data providers, and many actors involved. Another issue is that there could be excessive aggregation, that we get national level indicators that do not show how the picture is in specific areas. So we lose granularity. And also there are some restrictions on combining data sources due to lack of interoperable identifiers and data formats. So we can say the needs are increasing for more and more indicators and more additional data sources that should be utilized. So far, we see that there are underexploited data sources. And this is not only about the CAP, because it's a whole ecosystem. So the interoperability and the standardization between the components of the ecosystem is something broader and something that is yet to be achieved. There are a lot of ontology references in the agri-food domain, but some are specific to, let's say, some sectors, livestock sectors, some to crop, arable crop sectors, but some standards are more available than others. But we can see that in order to achieve data interoperability, there need to be more standardization efforts. I will not get in detail with interoperability, but it has various levels, that it can be something from a specific data format and a specific file, but also it can be it can be set in within the protocol of an organization, how an organization works. There are various standardization efforts and technical alliances in order to get and provide those data standards and the data sharing mechanisms. But most of those are parallel standards and not widely adopted, or if widely adopted, not in sectors that make it efficient. So this is why we have the common European data spaces, which aim to create a harmonized ecosystem for data sharing across sectors, with respect to GDPR, of course. The EU Data Act, which is applicable since September 2025, also provides the legal foundation of this ecosystem. It makes the farmer, with regards to the digital agricultural solutions, the owner of the data. And this creates other problems, like the farmer is reluctant to share the data because has no trust that these data could be used in order to impose compliance fines or penalties. And of course, with European agricultural data spaces and relative initiatives, more sector-specific governance groundwork is already taking place. Overall, so we can say that data interoperability could be addressed in a combined manner for both the agri-food ICT solutions providers and for the needs of the CAP monitoring implementation in order to bridge those two worlds.